Hello everyone. First I want to mention that recently I had my first subscriber on Patreon, and thank you whoever that is. And if anybody else wants to help my channel financially, I encourage you to do so on Patreon. Okay, so today I'm going to talk about a problem from the last year International Mathematical Olympiad, and it's functional equation. It's the first problem on that Olympiad. So we need to determine all functions from integers to integers, such that for all integers a and b we have f of 2a plus 2f of b is equal to f of a plus b. Okay, so first let's have several observations. So, like, the first thing that we notice about this problem is that we need to find all functions on integer numbers, not on real numbers, and this is like not kind of very typical for functional equations, and because of that, like, one idea that how we might solve this is to try to establish a recurrent relation to express f of x plus 1 in terms of f of x. So that could be one way how to approach this problem. Okay, so the second observation is that, like, as always, like in general in all functional equations, we need to try, the first thing that we need to do is to try to put some specific numbers into the equation, such as 0 or 1 or minus 1 or whatever, and also to try to like reduce it to some particular cases. So we need to try to put a equal b, or a is equal to minus b, and so on. And the third observation is that we need to get rid of this f of something on the right hand side of the equation. This is kind of the main obstacle in the equation, because we can't do anything with this f of something. We need to get rid of it. Okay, so the solution. So this is the original equation, and first we put a is equal to 0. So then we get this. So if we put b is equal to 0, then we get this. So notice that in these two equalities, the right hand sides are the same. So therefore we conclude that the left hand sides must also be equal to each other. So we get this, and this can be simplified to this, and this is so here we basically expressed f of 2x in terms of f of x. So now we can use this to rewrite the original equation to rewrite f of 2a in terms of f of a. So if we do this, then we obtain this equation. So now we are going to use this equation instead of the original one. Okay, so that's what we have. Now let's put a and b the opposite number. So basically a we put it to x, and b as a minus x. So then we get this, and this can be like, from this we can obtain we can express f of minus x in terms of f of x. So that's what we have, and then we put a is equal to x plus 1 and b is equal to minus x. So that's what we have, and here we rewrite f of minus x, like we use the equality that we got from the previous step to rewrite f of minus x in terms of f of x. So that's what we have here, and this can be simplified to this. So this is basically the recurrent relation. So we expressed f of x plus 1 in terms of f of x plus some constant. So that's now we can rewrite it in this way. So f of x plus 1 is equal to f of x plus some constant k. So first let's consider positive x. So if x is greater than 0, then we have this. Then we can integrate it further. So we can rewrite f of x minus 1 in terms of f of x minus 2, and so on. So until we get to 0. And basically we have we expressed f of x in terms of f of 0 and xk. So now we can do the same thing for negative x. Basically the same thing, only we go instead of x minus 1 we go to x plus 1. Then we get this, and so on. We go to f of 0. So, and this is also equal to this. So now we notice that for both positive and negative x we got basically the same formula. We have f of x is equal to f of 0 plus x multiplied by k. So now we notice that for when x is equal to 0 we also have the same equality. We can just verify it directly. So basically for all x, positive, negative and 0, for any x that is integer, we get this formula. So, and this formula we can rewrite it in the form that f of x is equal to kx plus c, where k and c are some integer constants. So now so we have recall that we have this original equation, and we obtain that f of x is equal to this. So now we put this formula into the original equation and determine which values of the constants k and c satisfy it. So that's what we do. So now we simplify it to this, and here we see that this must be equal to 0 for any a and b. So first we set both a and b to 0, then we get that the second part is equal to 0, because the first part goes to 0 from a and b. So then we put a and b both to 1. The second part we already proved that it's 0, therefore the first part without a and b, like the multiplier in front of a and b, a plus b, must be also equal to 0. So that's what we have, and now we conclude that so the first condition gives us that either k is equal to 0 or k is equal to 2. The second part, the second condition gives us that k is equal to 2 and c is equal to 0. So from this we conclude that we have two options. So either k, so first option is that k is equal to 2 and c is arbitrary, and the second option is k is equal to 0 and c is equal to 0. Both of them are zeros. So, and these two options give us two solutions. So the first is that f of x is equal to 2x plus constant c, where c is an arbitrary integer constant, and the second solution is that f of x is always 0 for any x. So, and finally, the final step, we need to verify that both of these solutions satisfy the original equations. This can be done directly. That's it.